All right, hello, HL students. We did not like the review very much today. That's okay. So I'm going to knock out problem two. It's got a lot of parts to it, so try to stick with me. First thing I'm going to do is just distribute out all the i's, j's, and k's and collect it back into a more normal form. So we have 2i plus lambda I minus 3 mu I plus 2 lambda j plus mu j plus mu k minus k. And then I'm going to rewrite it in terms of just the ijk as a column vector, 2. And then we don't have anything for j, do we? Doesn't look like we have any, just constant with j. And then k is -1. So that's our 0.2, 0, -1. Then one of our vectors is touching lambda, and that has an I component of 1, a j component of 2, and it does not have a k component, 0. And then I'm going to, that's all of my lambdas, and then all of my mu's touch -3, 1, 1. I believe I did that correctly. If you go back up, and some of you are able to just kind of switch forms like that from looking at the original problem. So 2, 0, -1, and lambda has 1, 2, 0, and mu has -3, 1, 1. Great. So what we now have are, these are two of our vectors in the plane. So we're going to cross product those wonderful vectors. So ijk, 1, 2, 0, -3, 1, 1. Cross product gives me I times 2 minus 0 minus j times 1 minus 0 plus k times 1 plus 6. I think I did that correctly. And that gives me the new column vector 2, -1, 7. And so that vector should be orthogonal. It should be normal to both of the other vectors that we just had. So that's our normal vector to the plane. And then to write the plane, we just dot product. This is our normal. We just dot product our normal with x minus our position vector. So these are my two direction vectors. That's what I cross product. This is my position vector. And so then to answer part A, finally, I'm going to take 2, -1, 7, and dot product that with x minus 2, y minus 0, z minus -1, in other words, z plus 1. Let's move my little face out of the way. And then that gives me 2 times x minus 2 minus 1 times y minus 0 plus 7 times z plus 1. And of course, that's going to equal 0 because we just took the dot product of a normal vector with a vector in the plane. And that's by definition going to have an answer of 0 because they're perpendicular. Now all we have to do is distribute it out. 2x minus 4 minus y plus 7. Let's erase that last part. I wrote a z instead of a 7. So we're going to do 7z plus 7 equals 0. If you move all your constants to the other side, they become -3. And you have proved what was asked of you, 2x minus y plus 7z equals -3. Great. That's how you do that. So then moving on to part B. Points A, B, and D lie in the plane, so you can plug them in. So point A, we're going to plug it in. So we're going to go 2 times the x minus the y plus 7 times the z equals -3. That's 4 plus 7a equals -3. So a equals -1. Point B, we're going to plug in 2 times the x minus the y plus 7 times the z equals negative 3. So that's 2b minus 4 minus 7 equals negative 3. So 2b is equal to, that's 11, add 11 over, we get 8, and that means that b equals 4. And then not C, that would be great. Point D here. Point D, we're going to plug it in. 2 times negative 1 minus D plus 7 times 0 equals negative 3. So negative 2 minus D is negative 3. So D is equal to 1. All right, so then we take those numbers and we're going to, let's see, so that's it for part B. We're going to take those numbers and we're going to try to find a parallelogram here. And so a parallelogram will have A, B, C, and D. And so a parallelogram would have AD being parallel to BC and AB being parallel to DC. And so we just want to find our slopes. We want to find our direction vectors. And so the AB direction vector, I'm going to write it just as a column between A and B. Let's see. So A goes from 2 to 4. So that's an increase of 2 in the x direction. It goes from 0 to 4. That's an increase of 4. And then it goes from A to negative 1. That's a change of 0 because it was negative 1 to negative 1. Then we're going to look at the column vector between B and C. So B goes, we don't know C yet. So let's just call C the vector, C the point X, Y, Z. We can't calculate the slope quite yet. We'll get there in just a second. So let's compute the, basically there's one way we could do it here is we know it has to be parallel. And so let's take what our points are for D. Point D is negative 1, positive 1, and 0. And so I'm going to use the same slope that I just calculated on the left side, 2, 4, and 0. And so that means that I'm going to go up by 2. So my x component should be 1. My y component goes up by 4, 1, 5, and 0. Now to double check my work here, I should take the slope of BC and the slope of AD. So the slope of BC is going from B to C. So let's see, B goes from 4 down to 1. So that's negative 3. Then it has a y coordinate of 4 to 5. So that's going up 1. And it goes from the z coordinate of negative 1 to 0. That's 1. Now let's just double check that we get the same thing when we go from A to D. A goes from 2 down to negative 1. That's negative 3. A goes from 0 to 1. That's 1. And A goes from negative 1 to 0. That's also 1. So it's a parallelogram. And so we found the point C as 1, 5, 0. Okay, so I'm going to pause for a second just to write down some of these answers so I don't lose them when I clear my screen. All right, now let's clear the screen. Moving on, to part D. Show that the point E does not lie in the plane. So we go 2 times the x coordinate minus the y coordinate plus 7 times the z coordinate equals, does that equal negative 3? 2 plus 2 plus 7 does not equal negative 3. Done. Now last, find the volume of the triangular prism. It's actually not a triangular prism. It's triangular pyramid. And the formula for that is 1/6 times the magnitude of the mixed product, A cross B dotted with C. What the heck do the A, B, and C mean? The A and B form the base, and the C is the other vector that's not on the base. And so that's going to be the vector that goes either from any of our points A, B, or C up to point E. Okay? So let's find a vector AB. Let's find a vector BC. This is like our quote unquote A. This is our quote B. And then we need to connect A, B, or C up to point E. And so let's just say AE. Okay, vector AB. How do I go from A to B? Vector AB is going up 2 in the X, up 4 in the Y, staying flat in the Z. Vector BC is going down 3, up 1, up 1. Vector AE goes from 2 to 1, from 0 to -2, from -1 to 1. Okay, did I do that right? 2, 4, 0 is correct. -3, 1, 1 is correct. From A to E is -1, -2, 1. That looks good. So now I'm going to do the mixed product. So we'll do the cross product of 2, 4, 0 with -3, 1, 1. That's going to be I times 4 minus 0 minus j times 2 minus 0 plus k times 2 plus 12, giving me this wonderful column vector, 4, -2, and 14. So that's my A cross B. Now I'm going to dot that, 4, -2, 14, with -1, -2, and 2. That gives me -4 plus 4 plus 28. And that gives me 28. And so then the final answer is 1/6 times 28. I guess it doesn't come out to be very nice. I don't know, 14 thirds. Cubic units. That is our volume of our triangular pyramid, ABCE. I hope you enjoyed watching that video. I'm going to make a couple more today and keep working on them the rest of this week. Happy studying.